Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem, gold mine problem. So this is a medium level question and has been asked by Flipkart, Amazon and Samsung. And the topic tags of this question are dynamic programming and algorithms. Okay. So the question says, given a gold mine called M of n by n cross m dimensions. Okay. So n rows and m columns. Each field in this mine contains a positive integer, which is the amount of gold in tons. Great. It's not really necessary to understand the units. So initially the miner can start from any row in the first column. So it's like you can start at any row in the first column. So there might be n rows, so you can start at any row. You can start at the 0th row, first row, second row, or the nth row, but make sure you're starting in the first column. From a given cell, the miner can move to the cell diagonally up towards the right, to the right, and to the cell diagonally down towards the right. Okay, so we'll see that in brief through the examples. Find out the maximum amount of gold which he can collect until he can no longer move. Okay, so no longer move in the sense he'll be reaching his or her last column. Okay, once you reach the last column, there's no other column to traverse, so that would be the last last position. So these are some of the examples given, and you need to solve this problem with the time complexity as O of n by m and n into m, and auxiliary space to be O of n into m. So in my case, my solution will not be using, I'll not be using any extra space. I'll be solving this in O of 1, and time complexity remains the same because we need to explore each and every possible each and every coin, like each and every grid we need to visit. So it's like O of n into m for sure, time complexity. But space, we are not using any extra space. We'll be solving this in O of 1, and n and m goes up to 500, and the value of each grid goes up to 100. Okay, so these are some of the things that have been given. Before I proceed further, I would like to mention few points. I'm getting a continuous comments about reduce the speed of the video, etc, etc. See, there are two things I'm keeping in mind before I upload a video. I'm making sure I'm putting everything in front of you, everything in the sense everything, like starting from deriving the approach and developing the intuition, and then framing the code as well. Many of the YouTubers do not do that. They directly attach the code in the video, like in the beginning of the video itself, and they just scroll their mouse over it and explain the things. But I'm not doing that, and because of this particular reason, my video will be lengthier. So for that, I'm increasing the speed of the video and then uploading on YouTube. It's a very basic common sense that there are tools on YouTube. Why do you only use 1.25 and 1.5? Why don't you use 0.75 and 0.5? Isn't it? You can even reduce the speed of the YouTube, right? The video, right? So you use that. So if you're not very comfortable in watching the video at a speed of 1.25 and 1.5, use it at put it at 0.75 and 0.5. Okay, so that is also a solution. So if you want video to be not linear, and you want everything to be covered, that's not possible. Some of the other you need to compromise, right? So that is one of the reason I'm urging you people to use speed tools, put it at 0.75, 0.5. If you're feeling at any point of time it's very fast or not understandable, use those tools. All right, and I'm also making sure I'm putting everything in the video from A to Z, everything, so that you'll be getting each and everything that's actually needed to solve this question, and it must be helpful to you in a long run, right? It's not like right now you'll be solving the question and it's done. So whatever video you're trying to watch, make sure it's helping you in the long term, okay, long run. So then only it's valuable. It's not like only for the particular question you see the solution and then submit it and then earn some coins, that's it, it's done. It's not going to help you anyways. All right, so anyways, let's proceed with the solution. So this is the example that has been given. Sorry for this thing, I was writing something and I forgot to erase that. So this is the example given. So let us explore why the output is 16. Okay, why the output is 16 in this particular case. So if you can carefully observe, the path that has been mentioned here is first start at 20 in the sense second row. Okay, second row. So at this particular position, 0th column, because it's been clearly instructed that you need to start at the 0th column itself. Okay, so 20 231. Okay, 20 231. 31 in the sense third row, first column. So come here. Okay, 5 6, and then 2 in the sense second row, second column. So this one. Okay, so this is also done, and then 2 3, that means second row, third column. So from here. Okay, so this is also done. So what is the total amount that you're going to collect? 5 plus 6 plus 2 plus 3, that is equal to 16. Okay, so if you traverse this particular path, so if I just erase these things, if you traverse this particular path, 5 to 6, 6 to 2, 2 to 3, you'll be getting 16. And also there is another path. What's that another path? So 20, starting from 20, 2 0 in the sense again the same thing, and then 1 1. So 1 1 in the sense first row first column, and then 1 2. 1 2 in the sense first row second column. So this one. So again 0 3. That means 0th row third column. So this one. So in total you're coming from here 5 to 2, 2 to 4, 4 to 5. Again, what is the total? 5 plus 2 plus 4 plus 5. That is actually equal to 16 again. Okay. So if you can clearly see, once you come here, you'll be stopping because there's no other columns to explore, isn't it? You're done. You're at the dead end. So there's nothing more to explore. So whatever the pathways that you have starting from the 0th row, so out of all those pathways, 16 is going to be available from these two particular pathways. So 2 0 3 1 2 2 2 3. This is one pathway. 2 0 1 1 1 2 0 3. This is one pathway. Only in these two pathways you'll be getting 16, and that is the maximum value that you can get. No other pathway you can get much more than 16. Okay, 16 is only possible, is the maximum possible that you can get, and that can be possible in two paths. Anyways, we are not interested in figuring out the exact pathway. We only need the maximum sum that we can get. So I hope you people understood why the answer is 16 here. Okay, now we need to figure out the approach. All right, first example I'm not dry running it because it's I'm not verifying it. It's very easy. So that's the reason I've taken example 2. Okay. So I hope you people understood why the output is 16. Now let us frame this approach. Before I solved this question last year, okay, last year I solved a particularly similar type of question. I would say exact question. Only there is one small change. I'll tell that later. I solved that question on lead code. What that question says is like I remember the question name to be prism, triangle prism or something. I'm not sure. So it's like this. So we'll be having some balls like this. Okay, so prism. Okay, let me write it properly and. Fine, you'll be having like this, okay, and let me write another row as well, okay. So, and each and everything will be having some particular sort of values. Like let us assume this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So what the question says, you need to figure out, like you can start at 1. Okay. You need to start at 1. You need to figure out a path. Okay. You need not output the path. You need to figure out a path such that you can get the maximum sum. So what are the available choices at any particular beat? If you're standing on this particular 4, you have the freedom of going to just diagonal left or left, okay, left bottom left, or right bottom or bottom right. So if in case if I just put it here, from 4 I can go to 7, or from 4 I can go to 8, from 4 I can go to 9. Only these are the three available options for me. Even for if you want me to write, you can go to 8, or you can go to 9, or you can go to 10. If from 6 you can only go to 9, you can only go to 10, you can only go to 11. Okay, so these are the constraints that have been given. So if you're standing on a particular bead, you can either go to the bottom left or straight bottom or to the bottom right. Only these three options are available. So out of these options, these many options, okay, so these many out of all these options, you need to figure out a pathway starting from 1. So 1 in the sense this particular, okay, this particular point, and so that you end up with the maximum sum. Okay, so all these things will be erased now. Shit. Anyways, I need to write it once again. Okay. So yeah, you need to figure out the maximum sum. You need to figure out the maximum sum. Okay, so you need to figure out the maximum sum. So how am I going to do? So for the very first 10 minutes, I was not able to solve this question. Okay, I was not able to solve this question. The reason being, I am exploring the paths from 1. I was like, from 1, okay, I'll go to 2. Now from 2, I'll go to 4. From 4, or 2 to 5, or 2 to 6, and again from 4, I can have a chances of going to 7, 8, 9. I was like exploring each and every pathway, and I was trying to cut out the things that are not required. I was thinking in that fashion, but I was not able to solve it for the very first 10 minutes. Then I changed my approach. I understood like, why am I actually working on all these things? Okay, why am I working on all these things? I must not work on all these things. Okay, because there is a repetitive issue. What is that repetitive issue? 1 depends on 2 and 3. Okay, 1 depends on 2 and 3. For 1, there are only 2 options. Like yeah, I should have like put another beat. Anyways, fine, let's leave it. So 1 depends on 2 options, 2 and 3. Okay, so 1's perspective depends on 2's perspective and 3's perspective. What is the perspective? What do I mean by that? So let us assume 2 has explored all its pathways. Okay, 2 has explored all its pathways and have figured out what is the maximum possible sum that it can get. Okay, let us assume it is x. And 3 also, let us assume 3 also explored all its pathways. Like from 3 it can go to 5 or 6, and from 5 it can go to 7 or 8 or 9. So every possible pathways from 3 has been evaluated by 3. Okay, let us assume 3 has evaluated all its pathways, and it has stored the value, the maximum value that it can get, and it is actually equal to y. Let us assume it is actually equal to y. Now you are on 1. What will you do? What is your primary duty? What is the only duty? If I say, what is your only duty? Out of x and y, you'll be choosing the maximum, isn't it? Maximum of x and y is what you'll be choosing, and you'll be adding it to your value. What is your value? 1. And this would be your final answer, isn't it? From 2, you have explored all the pathways. 2 says that it has explored all its pathways from itself. Okay, from its point. Okay, from 2, it has explored all the pathways possible. And the maximum that it can get is x. That's what it's telling. And 3 says it has explored all the pathways from its point, and it says y is the maximum value that it can get. So what is your duty now? You just need to figure out what is the maximum among these two and choose that and add it your value. What is your value? Your value is 1 because you're standing on 1. So just add that, and this would be your final answer, isn't it? So this boils down to the recursion. What is that? Because you're asking 2 and 3, what does 2 and 3 actually do? 2 and 3 ask its possible perspectives, isn't it? 2 depends on 4 and 5, because for 2 what are the options available? It can go to 4 or it can go to 5, and for 3 it depends on 5 and 6, isn't it? 3 depends on 5 and 6. And now again 4 depends on what? 3, it depends on 7, 8 and 9, isn't it? 5 depends on 8, 9, 10, 6 depends on 9, 10, 11, isn't it? So each and everything depends on the below 3, isn't it? So finally, if you're coming to 7, 7 depends on 3 values. What are those 3 values? 12, 13 and 14. And if you're coming to 12, does it depend on anything? No, it has nothing below it. So it's not going to depend on anything. So 7, if you evaluate from 7, 7 depends on 12, 13, 14. Depends on 12, 13, 14 in the sense, it can either choose 12, either choose 13, either choose 14. What are the maximum among these three? 14. So 7 says, okay, I'll be choosing 14 and I'll be replacing myself with 14 plus 7, because I have 7 initially. Okay, let us assume you're standing on 7. And from 7, you see that there are 3 possibilities. You can go to 12, or you can go to 13, or you can go to 14. Out of these 3, what's the maximum? 14 is the maximum. So you'll be taking 14 and you'll be indulging into yourself. So 14 plus 7, what is that equal to? 21. So you'll be updating this 7 with 21. Okay. Similarly, coming to 8, if you're working on 8, what are the available options for 8? 13, 14, 15. Out of 13, 14, 15, what's the maximum value? 15. So 8 says, okay, I'll indulge 15 into myself. So that would be 8 plus 15, that equal to 23. So this particular value will be equal to 23. This is no more 8. This is 23. Similarly, you'll update 9 to what's the maximum value available for it? 14, 15, 16. Out of it, 16 is maximum. So 16 plus 9, that's equal to 25. For 10, 17 is maximum. So it will be getting 27. For 11, 18 is maximum. 11 plus 18, 29. So this particular row, this particular row will be like 21, 23, 27, 20. Okay, I missed something. 25, 27, 29. Okay, this particular row, this particular fourth row is now like this. Now third row, like this particular values, 4, 5, 6. 4, 5, 6 are like this. 4, 5, 6 are like this. Now 4 sees what are the maximum values that it has. Like it can take out of 21, 23 and 25. 21, 23, 25 are the available choices. So 4 will decide what is the maximum among these three. So it says 25 is the maximum. So I'll take that into myself. So 4 will be replaced by 4 plus 25. That's actually equal to 29. And 5 will be replaced by what's the maximum available choices for it? 23, 25, 27. 27 is maximum. So 27 plus 5, that is actually equal to 32. And for 6, what's the maximum available? Out of 25, 27, 29, 29 is the maximum available. So 29 plus 6, that's equal to 35. Now this 4, 5, 6 will be replaced as 29, 32 and 35. Okay. Now on top of it, what are the things that it has? 2 and 3. Right. Now 2 and 3 will see what are the maximum value choices for me? 29 and 32. 32 is a maximum. So I'll replace 2 with 32 plus, that's equal to 34. And for 3, what are the available choices? 32 and 35. So I'll be replacing 3 with 3 plus 35. That's actually equal to 38. So now your thing is 34 and 38. Now you have only one choice, that's 1 on the above. Now 1 will say out of these two, what are the maximum? 34 and 38. 38 is the maximum. So I'll take 38 and I'll be inducting into myself. That's actually equal to 13. So this is the maximum sum that you can get. I hope you people are understanding. So from if you start from 1, you start, the maximum sum that you want to get is 39. Okay. I hope you people are understanding this approach. So basically you need to start from last but one row. Okay. Last but one row, not the last row, but last but one row. From there you need to check for the possibilities, and then you need to update yourself, and then come to the before row, and then come to the starting point. This is how you can explore all the pathways simultaneously, and you can even get the maximum possible value. All right. So if you can relate this same approach to the problem, the only thing here it has been changed is the shape. Here it is pyramid, but here it is rectangle, isn't it? Here it is like rectangle, like just a rectangle like this. So if I just draw the grids here, so just draw the grids here. Okay, draw the grids here. So every value, like if you're standing on this value, it depends on this and this. If you're standing on this value, it depends on this and this. And if you're standing on, I'll be writing different thing. If you're standing on this, it depends on this and this. And if you're standing on, okay, I'll be using this thing. If you're standing on this, you'll depend on this, this and this. And if you're actually standing on this, if you're standing on this, you'll be depending on these two. Okay, so that's it. And you'll be keep on updating. Once you have figured out this row, now we'll be evaluating for these particular points. Okay, you'll be evaluating for these particular points. Again, you'll update this thing and you'll be evaluating for these particular points. And that's it, you're done. And out of all these possible values in the 0th row, you'll be taking the maximum, values. So after updating, let us assume it is X, this is Y, this is Z, this is A, this is B. And you'll be taking the maximum among these 5. That will be your answer, right? So let us do the dry run so that you people will understand. So if I just take this particular point itself, okay, this is, so if I just write this in a matrix, so this would be like 1 3 1 5 2 2 4 1 5 0 2 3 0 6 1 2. So right now in this pyramid you're like going from top to bottom, but in this matrix you're having options like in this fashion. Like for one you have 2 options, you can go to 5 or you can go to 1. From 4 you can have 3 options, you can go to 5, you can go to 1, you can go to 3. From 2 you have 3 options, you can go to 1, you can go to 3, you can go to 2. From 1 you have 2 options, you can go to 3, you can go to 2. That's how we'll be solving this question. Okay, so that is how we'll be updating. So from 1, what are the options you have? If you're standing on 1, what are the options you have? You can go to 5 or you can go to 1. Diagonally I mean diagonally to the right side, or diagonally to the right, or diagonally to the top. To the top, do you have anything? I do not have anything, so I cannot go. So from 1 I have two options, 5 and 1. What is the maximum among those two? 5. So I'll be updating 1 with 1 plus 5, that is actually equal to 6. So in this case I'll be writing 6. Okay, and for 4, what are the available options? 5 and 3. What's the maximum? 5. So 4 plus 5, that's actually equal to 9. Okay, so I'll be updating this to be 9. I hope you people are understanding. Okay, so from 4 you can go to 5, or you can go to 1, or you can go to 3. Out of these 3, 5 is the maximum. So I'll be updating 4 to be 4 plus 5, that's actually equal to 9. And from 2, what are the 3 options? 1, 3, 2. So what's the maximum? 3. So 2 plus 3 equal to 5. Okay, so I'll be updating 2 with 5. Okay, I'll be updating 2 with 5. And from 1 you have again two options, you can go to 3 or you can go to 2. What's the maximum? 3. So I'll be updating 1 with 1 plus 3, that's actually equal to 4. So this is done. Now come to this particular column. From 3 you have two options, either you can go to 6 or you can go to 9. What's the best? 9. So I'll be updating 3 with 9. Okay, so I'll just erase this and I'll be writing this to be okay, just a second. So I'll be writing this to be 9. Okay, I'll be writing this to be 9. And from 2, what are the options that are there? I can go to 6, I can go to 9, I can go to 5. So I'll be going to this particular 9 is the best option that I have, isn't it? 9 is the maximum thing that I can go. So I'll just erase this 2 with 2 plus 9, that's equal to 11. From 0, what are the maximum that I can go? 9, 5, 4. These are the 3 options. So 9 is the maximum among these 3. So I'll be replacing 0 with 9. Okay, 0 plus 9, that's equal to 9. So coming to 6, again 2 options are there, 5 and 4. What's the best? 5. So replacing 6 with 6 plus 5, that's actually equal to 11. Okay, and now come to 1. So come to this particular point. So from 1, what are the 2 options are there? I can go to 9 or 11. 11 is the maximum. So I'll be replacing 1 with 1 plus 11, that's actually equal to 12. If you are on 2, you have 3 options again, 9, 11, 9. What's the maximum? 11. So I'll be replacing 2 with 2 plus 11, that's actually equal to 13. And that is 13. And from 5, what are the 3 options? 11, 9, 11. What's the maximum? 11. So I'll be replacing 5 with 11 plus 5, that is actually equal to 16. And when you're coming to 0, so what are the 2 options that are there? 9 and 11. So out of what's the maximum? 11. So I'll be replacing 0 with 0 plus 7, that's actually equal to 11. So out of all these 4, what's the maximum value? 16. Okay, so as said in the question, you can choose any row, right? At any row you can choose, but you must be in the 0th column. So that's the reason this is the starting point. 0th column is the starting point. In that starting point, what is the maximum value? 16. So this is the maximum answer. So yes, the output is 16. I hope you people understood how are we actually doing this, framing this approach and finally solve this question. So this is a very easy question. So why people are using an extra spaces? They are not manipulating the data that has been given, but I'm doing it. Maybe it's wrong, but like in the general software industry trends, it's not acceptable to manipulate the data, as many industries experts says. But in this question, I thought like why don't I just do it and solve this question? So that's the reason I've not taken any extra space. It's just like I'm updating this previous row, right? We are only dependent on the rows that are there to the to the right side to the columns that are there to the right side of it. If I'm working on this column, I'm only dependent on these 3, like these 2 values. Why should I take another vector and unnecessarily expand my space? That's no need, right? So that's the reason I'm not taking any extra space. I'm just solving it with O of 1 itself, just changing the data that has been given to me. So I hope you people understood what did we actually do till now. So just the dependencies on the next column and manipulating the present column according to it, and then pushing the same facts to the before columns, and finally coming to the 0th column, and out of the 0th column taking the maximum available amount. So that's it. I hope you people understood. So let us now frame the code. So initially take an variable like int answer to be 0. Now traverse for int j equal to the last but one column, j equal to m minus 2, j greater than or equal to 0, j minus minus, and for int I equal to 0, I less than n, I plus plus. Okay, so there are 3 cases here. So if you are working on the starting row, if you are working on the 0th row, you have only 2 options, either right or the bottom. And if you are working on n minus 1th row, you have only 2 options, either diagonally to the left, to the right side and to the top, or to the right. So you cannot go to the bottom because there's nothing like that. There's nothing there in the bottom. But if you work out somewhere in the between, you have 3 options, right? So for that reason, you need to write this clearly. So if your I turns out to be equal to 0, okay, if your I turns out to be equal to 0, you have 2 options. So you can write m of I like if your I plus 1 is less than n. Okay, if your I plus 1 is less than n, then m of I of j, I can add that to be maximum of m of I. What's the maximum to the right side? That is equal to j plus 1, and to the bottom, so m of I and m of I plus 1 and j plus 1. Okay, if your I plus 1 is not less than n, then you have only one possibility, like you can only go to your right side. Okay, so m of ij plus equal to m of I j plus 1. Okay, m of I j plus 1. So this is done. And else, if your I is actually equal to the last row, okay, if you are actually equal to last row, and if your I minus 1 is actually greater than or equal to 0, if you are actually greater than 0, then you can take m of ij plus equal to max of m of the top left, sorry, the right side top, so that is m of I minus 1, okay, m of I minus 1 j plus 1, and or to the right side, just the right, m of I j plus 1, okay. If in case it's not less greater than or equal to 0, that means you have only one option to take the right side. So m of ij plus equal to m of I plus, so your row will be the same, your column will change, okay. Else, if you are in anywhere in the between, so now take int temp to be uh, m of I j plus 1, so your right side, okay. In case your I minus 1 is greater than or equal to 0, then put temp to be maximum of temp and m of I minus 1 j plus 1, okay. So also if you're below, to the bottom, if your I plus 1 is less than n, that also you can take. So temp will be equal to uh, max of temp comma m of I plus 1 j plus 1, okay. So after all these things, add the maximum value, so m of I j plus equal to temp, okay, plus equal to temp. And finally, after all this, if you are actually in the zeroth column, answer would be equal to max of answer comma m of I of j, because if you are working on the zeroth column, you need to take the maximum of all the zeroth column values, and that will be your final answer, okay. So finally, written answer, okay, written answer. So I hope you people understood. Let us first compile this and see. I would say there is no mistake, okay. Let us submit this now. Okay, fine. It's working perfectly. I hope you people understood this approach. If not, just go through it once again. And time complexity is O of n into m, and space is O of 1, because we are not using any extra space. And this is a very good solution, dynamic programming itself. So there's nothing like big, problematic thing or confusing thing. It's very evident. It's just that we need to see from the bottom rather than seeing from the top, seeing from the bottom and then analyzing it, updating it, and then going to the top and top and top. Okay. So that's it for this video. I hope you people understood. If there are any doubts, please feel free to comment in the comment section. I'll be happy to revert back and help you on that. So thank you for watching, guys. Stay tuned.